Welcome to the Kserve video. My name is Daniel from Melio AI, and I'm here to show you what Kserve is, how to make your model compatible with it, and lastly, to run inferences on it. Knowledge of Docker will be required for this video, so if you haven't watched it, please go watch the introduction to Docker video. Okay, let's get started. Kserve is a serverless inference platform that deploys machine learning models in production environments. We have chosen Kserve over other popular server mechanisms because it is cloud agnostic, serverless, and scalable. Highwind uses Kubernetes to orchestrate its containers. Basically, Kubernetes allows us to automatically scale containers up or down, and automatically restart them if there are problems, which is something that Docker on its own cannot do. Kserve extends the Kubernetes API to serve containerized machine learning models at scale. To clarify on what is meant by serving models, Kserve allows us to host the model on the cloud. It also creates an API for us to interact with the model, as well as handling any requests made to the API. And scaling is managed based on demand. When it comes to deployment, the model itself only makes up a small part of the total solution. It usually requires teams from different departments to deploy the model into production. Kserve is becoming increasingly popular as it makes deployment easier, saving us time and money, as well as avoiding bottlenecks when we need to scale. For inference, Kserve uses a predictor. A predictor is basically a model wrapped around by the model server. This API is what allows us to communicate with the model and receive responses. The model server is actually based on FOSS API, which gives us support for the Open API spec and Swagger docs. Before we can start using Kserve, we need to make sure our models are compatible with it. Since we are using custom models, we can't use the standard runtimes. We need to use the custom serving runtime using Kserve API and the version 2 Open Inference Protocol. We saw earlier that the Kserve API is the model server which wraps around the model and allows us to communicate with it. To use the API, we must use Kserve model as a base class. Kserve model defines three handlers: pre-process, predict, and post-process. Pre-process prepares the data and passes it to the predict method. Predict executes the inference for your model, and post-process helps to turn the raw result into something that is more user-friendly. Then load is for loading the model from storage into memory. Kserve uses the Open Inference Protocol, which allows us to run inferences across different serving runtimes. And due to standardization, we can migrate our models from one platform to another. For Highwind, we are specifically using version 2. This inference protocol makes post requests to the endpoint with two JSON objects: inference request and inference response. So what does it mean to be compliant with the protocol? Kserve requires your JSON objects to match their exact structure and format. Let's take a look at the compliant inference request on the left. Here we have the keys ID, parameters, inputs, and outputs. Now let's take a look at an inference request that is not compliant. We can see that the keys are different and having the wrong data type will break compliance. Now we can see a correctly formatted inference request with the optional keys removed. But there's still something we haven't looked at. We haven't looked at what the request input is. Inside of the inputs key, we use request input. Notice that request input also has a structure and format of its own. On the right is an example of what it would look like inside of inputs. Then we have the same story for the inference response. Outputs contain the response output, which all follow the same structure. For more information on the keys, please take a look at the Kserve documentation. So why should we follow this protocol? It would be very difficult to work with payloads that have different formatting, and it would not be possible to automate it. When we have a consistent format, it's easier to create the logic as we know how to deconstruct the payload and find the actual data. In turn, you'll always get back consistent responses. You are what you eat, as they say. Let's look at how it all works together. When Kserve starts the model server, the pre-process, predict, and post-process handlers are ready and waiting for an input. We send the input payload to the model server, where it will be used by the pre-process. The payload, known as the inference request, must match the version 2 inference protocol, or Kserve will reject it. Once the input has been processed, it is passed to predict and an inference is made. The output is an inference response, which is also compliant with the inference protocol. If further processing is needed, the output is sent to post-process. Now that we've seen the components of Kserve, let's take a look at how we can deploy your model on Highwind. We will be using the iris classifier as an example, and we'll go through how to make it compatible with Kserve. For some context on the iris classification model, it is used to determine which species a flower belongs to, namely Setosa, versicolor, or virginica. In the input data, each row represents an instance or observation, and the variables are the sepal length and width, and the petal length and width. We then get an output of integers 0, 1, or 2, letting us know if the instance is Setosa, versicolor, or virginica. A written tutorial is also available in the Highwind documentation if you want to try run it for yourself. So we have already trained the model, tested it, and now we are ready to deploy it to Highwind. It is recommended to create a dedicated folder called deployment so that we can keep all its related files together. Here, I have already created a deployment folder along with the Python script for Kserve. I have also created the Docker file and Docker Compose file so that we can create an image for our Docker repo. Kserve will need our model, so I'm going to make a copy of it and move it to our deployment folder. Now we'll need to create a main.py file. This is where we'll create our own class to work with the Kserve API. These are the libraries that we will need, and this is the location of the model which we copied in earlier. Let's look at the class myModel. We can see that we are inheriting from the Kserve model class. From the model class, we will be using the load, preprocess, predict, and postprocess methods. First, we have our constructor defining the name of the model itself, and the scalar. Let's take a closer look at self-ready and load. Load is used to load the model into memory, and since it is in the constructor, the model will be loaded in during startup. Self.ready is used to tell Kserve if your model is ready or not. If the model is not ready, Kserve API will not be able to receive inputs for prediction. At the very beginning, we set this to false. In the load method, we define the models that we want to be loaded. Here, we are using the model and the scalar from the saved model folder that we copied in from before. Once the models have been loaded, we set the model state as ready. Kserve API will now be ready to accept inputs when the model server starts. In preprocess, here we are going to convert the data to a NumPy array and scale it. Notice the payload parameter type uses inference request. This is our input. It must match the inference request shape of the version 2 Inference Protocol. We can see that our input is compliant with the Inference Protocol and can be used by Kserve. Once preprocess is finished, we take the data and pass it into the predict method. In the predict method, we make an inference based on the model and the processed data. Here, we'll get an inference response as a return. Again, the JSON object must be compliant with the Inference Protocol. In our case, we don't need to use postprocess as no further changes are needed. The argument parser is used to get the name of the model from the command line argument when the script is run. We will create the command line argument in the Docker Compose file. In model, we create an instance of myModel with the name of the model passed in. In modelServer.start, this is where Kserve will start the model server, ready to serve prediction requests. When an input is received, it'll trigger the preprocess and predict methods. Once we have all of that ready, let's test our model by starting up Kserve locally. First, we'll need to create the Docker file to build the image. This is very similar to the fast API containers which we created before. Here, we will use the Python image as our base image. We also specify that we want the Linux version of it. The work directory is set as app. We copy in the requirements and install it via pip. We also copy in the model and the main.py script into the subdirectories of the work directory. Then we start the script with the entry point. To run this image locally, we will use the Docker Compose file. Here, we'll start the Iris Inference util service, give it a container name, and use the image we just built. In command, this is the command line argument that the arg parser will read from and get the model name. In this case, the name of the model is just model. Then we set the work directory and define the ports so that we can access the model server. Remember that Kserve is based on fast API. Now we can start a Kserve container by running docker compose up-d so that it runs in the background. Next, we're going to pass in the input JSON file to the Kserve model server. For Linux or Mac users, you can use curl to achieve this, but since I'm on Windows, I'll use the PowerShell equivalent. Basically, we'll make a post request to the model server and use the input JSON file as a payload. Once the file has been posted, the server will trigger the preprocess and predict methods and will return the inference response to us. Now that I have the output, I'm just going to format it so that it's easier to read. If we compare it to the inference response, we can see that it is compliant with the Inference Protocol, and the output is what we were expecting. We can now say that the model is working and is ready to be deployed to Highwind. We have looked at making your model compatible with Kserve, containerized it, and ran inferences on it. We are almost ready to deploy to Highwind. Now, I've only shown you Kserve within the scope of Highwind, so I highly encourage you to use the documentation while you're working on it. Alright, that's it for now. See you in the next video.